Hello students. So in the previous online class video we were discussing about the optical instruments. That's the last part of the ray optics concept. So today what we're going to do is we are just going to continue with the same topic, that is optical instruments. So in the previous class we have discussed about simple microscope and compound microscope. So microscope definition also we have learnt. So what is the definition of microscope? It's a device which is used to enlarge microscopic objects. In the sense, very minute object we can enlarge into a big scale. So next is something like one of the most advanced one. That means we can see or we can view very far away places, and enlarged image of that one. We can view that very nearly. So that is what telescope means. You may be familiar with telescopes or binoculars, all those things. So today what we do is we'll discuss about telescope. That is also the one more type. That means initially we discussed about microscope, first optical instrument. Let us go for the second optical instrument, that is telescope. So this is how. So now telescope means, of course, we can view far away objects, far away places very nearly. So all those are the advantages, correct? But right now like astronomy, we can view very far away galaxies. All those images can be traced, can be visible because of telescopes. Huge telescope will be there in different space stations, all those. So whether the same telescope which is used to view celestial bodies can be used for viewing a long distance on the Earth's surface, the answer is no. Why? Because all the celestial objects are in which shape? Spherical in shape. Why spherical in shape? Because they tend to minimize their surface. That is why spherical in shape, correct? So now suppose you see a moon in inverted way also, there is no, what we can say is, suppose it is inverted also, there is no big deal at all because it's already spherical in shape. Suppose you view any building or tree, something like that. Suppose the information is inverted, means it's very difficult for us to understand that. So that is why whatever the telescope which is used to view celestial objects cannot be used for geographical locations, to view geographical locations. That is why there are two types of telescopes. So first one is terrestrial telescope. One more is to view celestial bodies. It is astronomical. Astronomical telescope. So optical instruments we are discussing. In that, microscope already we have discussed, and much more about microscope, like what and all definitions are there for microscope, what are the equations that can be understood. I am going to discuss that once I finish off all these ray diagrams, because these are important for 2 marks. So once we finish off the ray diagrams of different optical instruments, then we can go for the small theory part of these individual optical instruments. So astronomical telescope, yes, of course. Then terrestrial. So terrestrial means, for geographical locations on Earth's surface we can use terrestrial telescope. So what about astronomical telescope? Yes, for celestial bodies. So here inverted image will be there, here non-inverted straight image. So now what we are going to do is it's already asked in the previous examinations, that is draw the ray diagram of a telescope or astronomical telescope. So now what we are going to do is ray diagram of telescope. So in the microscope, compound microscope, ray diagram, I think it is clear for you people. So suppose you compare different books, small variations will be there in ray diagrams. So what I discuss here is, you can follow this one, or suppose you go for NCERT, in that way some small variations might be there. But remember, in the previous microscope, the inverted image is there, right? From the objective to eyepiece when it comes, the image has to form in between principal focus and optic center of the eyepiece. Then only enlarged image is possible. So just make sure that, okay? Suppose anybody got confused with some other books, it is like that, so it is different. No, all are same itself. But main thing you have to stress is the inverted image from the objective have to fall in between optic center and principal focus of the eyepiece. So small variation might be there, like position of the rays and all. Nothing to worry about that. All that we require to do is we have to get the enlarged, okay, inverted image. That is it. Okay. Next, leave it. Let us go for the telescope concept now. So now what I am going to do is I am going to use the ray diagrams. That means we will draw the ray diagrams because it has got how many marks? 2 marks. That is why. Okay. So I will take this one as principal axis. Fine. And you might be remembering in the previous diagram, that is microscope, we had bigger objective. Okay. Objective was bigger, but here, in the sense objective or eyepiece was bigger there, and objective was small. That means eyepiece was bigger. Why? Because we have to gather the large information, more information we require from the minute object. That is why eyepiece was very big, whereas that particularly objective lens was small there. Correct. Because why small? Because minute object we are going to enlarge. So small is if so means it is enough there. But right now it is all about the telescope where we are going to get the enlarged image of far away places, right? So for that sake, what we require is we require a lens which will capture or which will receive more amount of light, and that will give us the information. So suppose the lens which is there in front of the telescope is very, very small, means very less amount of light will be entering. That is why what happens, the information which is received also will be having the less clarity. All those stuffs will be there. Okay. So now what we are going to do is here telescope, that is astronomical telescope we are discussing. Terrestrial telescope we are not discussing. It's not there in the syllabus. That is why astronomical telescope we are discussing. Here what happens is we will be having a objective which is bigger. Okay. Why? Because it has to gather or receive more light. That is why. So thin lens it is. Okay. Okay, like this. Fine. Next, you can exact limit it has to come like this. Exact half of the, yeah. Next, right now what we are supposed to do is telescope means of course for a large distance, long distance. That means how we can understand from that where the object is placed, far away place. That means from infinity we are supposed to consider here. Okay. So that is why what we are supposed to do is we have to consider from infinity light rays are incident on which one? On the telescope. Like that we have to take. So from infinity, that is why I will take a ray of light which passes undeviated through the optic center. Here optic center I will take in this way. Okay. With small angle. Like this I will take. A ray of light passes like this. Parallel to this, I will take 2 more rays like this. From infinity, we are getting rays of light like this. So now you can make out a ray of light which passes through the optic center. We know undeviatedly it will pass through. But what about the rest of the rays, parallel rays? They won't go straight. They has to bend, correct? So what happens is they bend like this. They have to bend like this. And what about this one? It will bend like this in the upper direction, forming the image at exactly like this. Fine. See? So this is the objective. That means face of the telescope. All these things should be placed inside a chamber. You can see a cylindrical shaped chamber. Telescope, I think you have the idea. Okay. Next, right now, a bigger lens we have. Right now, what we are supposed to do is we have to get a lens which is having the smaller, what is that we can call, aperture. Okay, in the sense we will draw that here, somewhere here the lens I will draw. Okay, eyepiece will be having smaller that means size will be small here compared to the microscope, because we are discussing about which one, that is astronomical telescope. Correct. So now what I do is I will draw the lens here. Compared to objective, eyepiece is smaller. Okay, so like this. So rays of light actually in this way. So next we have to watch, in the sense the person has to view this one from this particular point. Okay, so he has to view that from that particular point. And next what happens is, so let me slightly increase this length, okay, because at this particular point slightly I will increase this. Why? Because the ray have to just meet like this. Okay, fine. So now this ray of light, when the person sees this, because again what happens here, they start bending like this. This also will start bending in this particular way. Correct? Because that ray of light when enters the secondary, that means the second eyepiece here, it has to bend again like this in this particular way. So when it is retraced back, okay, how it is retraced back? Yes, in this particular direction. I will use some other color. So maybe blue color I will use. So when it is retraced back like this, whatever the image formed will be like this. Okay, so these rays of light will enter this one. So let us not continue this. See, a clear image of ray diagram of this one we have formed. This ray will, of course, go for which one? Optic center, undergo refraction. Okay, I will explain once again. So next, what we can understand from this is, so different angles which are formed we can see from there. Then here image is formed, inverted image. Okay, thereafter a ray of light I will take from this particular point, okay, in order to just make a arrangement. One more ray of light I will take. You can see here all these are parallel to each other, correct? See, like this. So there are some angle which are subtended. Later on, when I give the equations, I will use these datas. Here some angle subtended with this particular objective is alpha. Angle subtended for the rays of light, this will be beta, like this. Fine. Next. Now image is formed here, but when it's viewed from the eyepiece, it's viewed like what? Image at infinity, because parallel rays of light, they won't meet anywhere. So of course, when they don't meet anywhere, of course it is not possible to form what? Image. So it looks like what? Coming from infinity. That is what the technique behind this particular astronomical telescope. So we can see the image. Okay. So from infinity we are getting the parallel rays of light, and when it enters to the objective, which is physically in the sense it's bigger in size, and thereafter because of the refraction they will meet at a particular point, it will form the image of a faraway place or faraway object. You can see here. Yes. So then next, what happens? I can give the name AB, okay? This is A, this is B. Thereafter, again refraction takes place at the eyepiece, and when the person is looking from this particular point, means the image looks like what? Yeah, from the infinite place, or image will look like what? Image at infinity. But it will be very clear, it will be visible for them, it will be slightly enlarged one. That means far away celestial body, okay? That means stars, or what is that? Planets or asteroids, comets, whatever. Okay, we can view from that. So this is a basic diagram of each one astronomical telescope. So next, what I can write? Yes, the distances. See, image formed here. So I will take this one as the focal length, f0. Then what about eyepiece? Eyepiece I can take here, fe, in this way. Okay, and remember, this particular point is there, right, where the image is formed, because I already told you people, in case of microscope, the inverted image which forms because of the objective has to fall in between where? Principal focus and optic center of the eyepiece. But here, the technique of this telescope is, the inverted image which is due to the objective is there, right? They have to fall on which one, you know? You can see here. Exactly on the, what is that? B I will write here, okay, AB, this side. Exactly on the principal focus of the eyepiece. So while designing the telescope, what they do, they will set such a way that the image because of the objective will fall on a particular point where exactly on the focal length of the eyepiece it has to form the image. Then only we can get a clear image which looks like it is at the infinity. Okay, so that is the thing which we have to understand from this. So you can see here, that is, person has to view from this particular point. This is eyepiece, this is objective. This is the image which is formed because of the rays which is coming from the infinite far away place. And of course, what is that? The objective is there, right? So this is the principal focus of the eyepiece, and exactly at this particular point itself, okay, so I will write one more here, that is principal focus of objective also should be there. So what we can understand from this, so sorry for this, I'll write it together, okay, no one want any confusions. FO comma it is, okay, this is A, this is B, fine then. So I think it is visible for you. Look at here, F0, that means FO, FE. So when image forms here, what happens? The image should exactly fall on the principal focus of the eyepiece. That means, of course, where exactly image forms here? Of course, because of the infinite distance parallel rays are coming means, of course, we know when the image forms, that should be exactly on the principal focus of the objective lens. Of course, you know, right? For example, if a ray of light is coming like this, parallel ray of light coming and incident on given this one means, it has to form image, right? Basic. That means, what is this actually? Focal length of a lens. Same. So, need not explain once again, I think. So, this point is there, right, where the image is formed. That will be the principal focus of objective plus principal focus of what? Yeah, of course, that is eyepiece. So, when they design that, it has to be like this. So, how to design that? Of course, lens makers formula, all those things we have discussed. We can vary the aperture, we can vary the focal length, power of the lens, different concept is there. That is how lens maker formula is very essential for designing the lens. So I repeat once again, what and all things will be there in astronomical telescope? Yes, there will be objective, eyepiece. Eyepiece means from the lens through which we are viewing. So objective lens is much bigger than compared to eyepiece, because large amount of the large information it has to receive, more light has to pass through this. So parallel rays of light from infinity will incident on this one. What is that? Objective. They will converge at a particular point. Of course, what is that? It should be the principal focus of the objective. But while designing this, what should be happening here? Yes, principal focus of eyepiece also should coincide with which one? Principal focus of objective, such a way that they have to, what is that? There has to be, what is that? Built, in the sense designed. So next you can see principal focus of this one is here, this one is also here together. So once the rays of light after formation of image, they go like this, again parallel rays of light will be there. So in this particular case, what we can understand from this is, yes, okay, like this, let it be just a reference line. Okay, don't want arrow mark, let it be. Fine. Don't want arrow mark, just reference line. Okay. Yes. So that is it. So this is angle beta, this is angle alpha. Regarding the angles, angular magnification, all those I will explain at the end, because right now we just require to understand what is the ray diagram of microscope, telescope, all these things. Okay. So now question is, right now, yes, this is suitable for astronomical study. Why? Because celestial bodies are actually spherical in shape. Suppose you view them in the inverted way also, nothing will happen, right? But problem is, when you use the same telescope for the geographical locations, for example, faraway place, for example, you might be knowing, for voyages, in a sense, when they go through the sea routes, when they want to see the faraway ships and all, suppose they use this particular kind of telescope, means the whole ship will be inverted, then what kind of information they will get? It's very difficult. So for that, what they do is, almost same kind of telescope they will design, but 3 lens will be there, in which case terrestrial. 3 lens, one more lens will be there in between, which will make the image again, what is that? Inverted, again erect it will be. Here 2 lens, in which case astronomical telescope 2 lens, terrestrial telescope 3 lens. That is how they will make the image, the inverted image again to be erected. Okay, erect kind of image will be getting by using which one? That is a terrestrial telescope. So diagram, I think this is clear for you. Okay, neatly you have to draw. And I hope everyone is taking this very seriously, because we don't know soon after lockdown whether we are going to start with, from the start we are starting the portion, or the government already, that means directly we are going to start from where exactly we have stopped in the online classes. So that is why whenever we discuss in the class, we have to take down very seriously. You have to note down the notes, and I told you people already what and all things you have to do. First you have to note down all the points which is discussed here, ray diagrams, all those things, and once you complete your notes, you are supposed to take what? Yes, you are supposed to take the picture of that, and you have to send me, because already I am maintaining which one, that is attendance. Already I am maintaining a separate attendance for you people, those who are doing work, and those who are not doing the work. Already, yes, we are going to, take separate measures on them, because we have the parents' contact. That is why. Okay, fine. So hope everyone will do the work sincerely. So because right now you are at home, you are free, so whenever you get the videos, watch properly, thoroughly. Any doubt is there, mean you can ask me, because you people have our personal contact number. Okay, so fine then. So this is all about, what is that? Astronomical telescope. Telescope means which one? What is that? Telescope means it's a optical instrument which is used to view the faraway objects. Two types are there. One is astronomical, one more is terrestrial. Terrestrial means it's used for geographical location. Some says one more word is a geographical telescope, they say. But the scientific name what they have kept initially is that is terrestrial telescope. So we better follow this one itself. So how many lenses will be there in terrestrial telescope? Because 3 lenses. Why? Because they have to make the inverted image again erect. That is why one more lens will be used in between. So that is it. So that is all about telescope concept. So I think this is clear for you people. Okay. Okay, students. Then what we are going to discuss next is regarding the telescope itself. We have seen the ray diagram of astronomical telescope, and I told you people what's the difference between astronomical telescope as well as the terrestrial telescope regarding the lens, number of lenses. Now, when we use this telescope which are made up of lenses, suppose you want very high clarity of the images formed. That means the lens has to be made from a pure material, so it becomes more and more costlier. Why? Because suppose you have the DSLR camera, and suppose you want to go for a wildlife shooting, photography or something like that. You might be knowing in National Geographic Channel, and they will be using the telescopic lenses, very lengthier. So they are very costly. Why? Because 10 lakh, 20 lakh, till that range it will be expensive. Why? Because that kind of lens they have to manufacture. And lens is made up of glass, how they manufacture glass, all those things. So they become more and more expensive. So suppose we want to build a very big telescope which will give lots of information regarding celestial body, means they have to build very big, what is that, lens, and we cannot depend more on that. Why? Because they become more and more bulkier then, correct? Imagine a very huge telescope is designed, means that much huge, what is that? Yeah, what we can say is, for example, glass, in the sense lens will be very big, huge it will be, and very difficult to manage also. So for that sake, because expensive, of course, one of the thing, and when light is slightly less, means clarity also will be reduced. That is why they introduced, in a sense, scientists introduced the reflecting telescope. Okay, reflecting telescope means they are not using this objective, all those things. Just lens will be there just for the purpose of magnifying, but they will use just mirrors. Okay, so using mirrors also you can design telescope. So now last topic from this particular chapter, that is reflecting telescope. So what is the advantages of this particular reflecting telescope? Is very easy to manufacture. First of all, just mirror. How to manufacture mirror? Yes, silver oxide we require. So easily, because this will give more information, because when light falls on a mirror, means around 98% of the, what we can say, light will be reflected back, correct? So that is how. So using the concept of reflecting telescope, it is easy to understand the information which is received. So from far away galaxy, imagine this much little amount of light is coming towards us, and suppose a big lens is used. Because of the metal of the lens, when it absorbs some of the light, the clarity won't be good. That is why, to get the maximum resolution of the images, more resolution of the image, more clarity, and less bulky, in the sense it has to be less weight, also should be less comparatively, and cost also, designing cost also should be less. For all these reasons, reflecting telescope is best. Okay, I think you understood the concept. Okay, fine. So reflecting telescope means whether it's a team which is designed or a person. So actually it's a scientist. His name was So you can see here, कैसे gran, okay. So कैसे gran, IAN, okay. Yes. So this is कैसे gran rain. Sorry, let it be RAIN. So pronouncing fine, whatever. So Cassegrainian telescope it is. So the scientist name is Cassegrain. So he actually designed that particular, what is that? A telescope which is a reflecting telescope. So what we call that particular reflecting telescope is Cassegrainian telescope, okay? I is there, okay? Cassegrainian telescope. So we are discussing about reflecting telescope, and in that one, who's the scientist who developed this particular kind of optical instrument is, that is Cassegrain, and we are going to discuss about his telescope which he designed, that is Cassegrainian telescope. So what and all things are there? Let us see. So first, what should be there? Let us see. First, there should be a chamber like this. That means hollow cylindrical shape. It should be first initially like this. That means cylindrical in shape. That means light has to fall inside so that we are able to make that reflect the light. That is why. And next, there will be a domed shape like this in order to make the light to reflect. Thereafter, this particular point will continue where there will be a lens. That means eyepiece will be there. A small lens will be attached to that, so that whatever the image you are going to get at the end, they can just slightly magnify that so that it's very easy to view. So this is the like this. Next, what will be there in that is this particular what is that telescope is completely, what is that, silver oxide coated from the outside, so that everything inside this one will be like reflecting, correct? That is why. Double layer you do like this, okay? Yeah. So you can just do some shadings. Like this. So next, so entire thing, that is objective mirror it is. So there will be a cylindrical shaped object here. Just take this one, this will be eyepiece. Next, let us take rays of light, okay? Different color chalk I will use. So a parallel ray of light, imagine from a faraway galaxy, parallel ray of light is coming like this. Here also I will take parallel ray of light. So once it reflects, okay, of course, because from inside this one is entirely, what is that, silver oxide polished from the outside. That means the inside of this particular telescope is completely reflecting at this particular point. So next, what happens when ray of light reflects back, right? So if it reflects back means it may go like this, then series of reflection it may go out. So right now whatever the light has come here, it has to be again made to go through this particular eyepiece. So how to make that? Of course this will reflect now. So for that sake what they do is, there will be a secondary mirror. What will be there? There will be a secondary mirror like this. A secondary mirror will be there. Okay. Then when ray of light reflects, slightly here I will do, reflection takes place. Okay, I think it's visible for you. So soon after reflection from this particular point, the ray of light like this I will take. Okay. You need not make exactly at the middle, so slightly you can take from this side also, it's okay. Like this I will do, okay. Fine. Soon after reflection, the ray of light okay. So reflection takes place from here. This reflection takes place from this particular point. You can use the scale with proper measurements, okay, easily you can do this. So ray of light will reflect in this particular way. So when you retrace that in this particular direction, this will be the principal focus of this particular mirror. It's a very simple diagram. So this eyepiece is there, right? I'll just extend till here because image is forming in this particular point. So like this. This is the eyepiece. So once I complete the diagram, then only you better draw this. Okay, fine. So small extension I have done here. So now from infinity, look at here, from infinity, rays of light, two parallel rays of light I have taken. Why? Because minimum two rays are required for which one? For the, yes of course, formation of image. So two rays of light, once it incident on the objective mirror. This is the secondary mirror. So I will write on here, secondary mirror. So once it strikes, gets reflected again, because this side is reflecting surface. Can just show like this in order to make it more clear, and they are actually received by the eyepiece. So what happens here, that is the image looks like what it has come from this particular point because of reflection. So this is the technique of Cassegrain telescope, which is a reflecting telescope. And advantage of reflecting telescope I have already explained to you people. They are less expensive and they are less bulky, and they have got more resolution of the image, more clarity will be there. Okay, so all these are actually the benefits of reflecting telescope. Okay, so that is all about reflecting telescope. So now reflecting telescope itself, which is used widely, okay, comparatively, terrestrial telescope means yes, okay, fine, because they'll be using the lenses. For astronomical telescope, using lens is very less nowadays, because they're using the which one? Yes, Cassegrain telescope model, in the sense reflecting telescope. Why? Because it gives more information, it receives more amount of light. So that is why this is important. Okay. So hope this is clear for you people. So the objective lens condensate light, you can see here the eyepiece is there, objective mirror is there, and secondary mirror is there. Once a ray of light falls on this particular reflection takes place. So all these are actually the basics regarding the reflecting telescope. Okay, so hope this is clear for you people. So regarding the equations for the magnifying, all those things we can discuss in the next video. So that in that I'll be explaining all about the how angular magnification is possible, all those. So right now we have discussed about the ray diagrams of all these optical instruments, which are important for 2 marks. So draw neatly and take down in the notes. Okay, fine.